So welcome to ProtoCAM. My name is Ed Graham. I'm the engineering manager. Today we're going to talk about the evolution of 3D printing and additive manufacturing. And I know you guys are probably looking at this like, well, how far back are we actually going to go with this? Because that's probably like a Commodore 64 on there. This is not my dorm room computer here, but what this is a picture of is the very first SLA machine. And this was developed back in 1983 by Chuck Hull. So this has been around, the technology has been around for quite some time. Chuck Hull started 3D Systems, and this was his very first prototype. Even he was prototyping prototypes at that time. So it wasn't until 1986 that SLA Technology became commercially available. And if you look at the image over here, it kind of looks a little fuzzy maybe, and in reality in 1986 the parts probably were. So they were very, very delicate. I don't know if any of you guys had any experience with early SLA parts, but they were very delicate, very brittle. The last thing you wanted to do was give them to your salesman, because in short order they were destroyed. In 1988, another technology came on the scene, and this is Selective laser sintering. Ron Belknap and myself actually had the privilege of sitting with the inventor of this technology, Carl Decker, as Ron and I sat at the table. We're looking at this part like, that looks like a burnt up marshmallow or something. How does anybody get excited about that? But for him, it was everything. It was his invention. It was something that he created, and actually, for the first time, he made something. And this was his something. So within the 2 years there, from 1986 to 1988, two different people were developing means of helping people develop prototypes. There's an obvious demand out there to help speed up this prototyping process. How do we get to market faster? In 1991 came along Stratasys, Scott Crump. If anybody in the room talks about 3D printing, this is probably the technology that you would think of when you think of 3D printing. It's a filament-based system, the lead whacker. If anybody has printers, they probably have a form of this, whether it's an industrial level one or maybe a consumer grade version of it. So the real demand, why were these guys on this track? Why were they trying to create these technologies? And the reason was because we had to find a better way to create prototypes without going through the expense of injection mold tooling. Injection mold tooling is very expensive, long lead times, and when you make a part that drops out of there and the rib is off by a certain amount and it doesn't work, well, you just cost a whole lot of time and a whole lot of money. So there was a real reason to get out there and create prototypes for design validation, form, fit, and function, reverse engineering, all different reasons of why everybody was on a mission here to create a process to help create prototypes quickly.